Good afternoon, ladies and gentlemen. Our objective for today is that students will be able to determine the volume of a cylinder. So yesterday we were looking at the volume of rectangular prisms. That's just a fancy word for something that looks like a rectangle, right? So we got a box. We said, okay, the way we find the volume is we're going to take the length, multiply that by the width, multiply that by the height. But every object that we encounter isn't always going to look like a box. So you have different formulas for different types of shapes that you're looking at. And we're going to start exploring at a couple of shapes that involve circles. So to start, we're thinking about something called a cylinder, right? Now, you might not be familiar with the word, but everybody has pretty much seen a cylinder at some point in their life, right? Whether it's a bev that you're drinking during class when you're not supposed to, like your Arizona iced tea, it's a can of soda, maybe a can of beans you have in the cupboard or some corn. Those are examples of cylinders. Now, just remember when we talk about volume is basically just a measure of how much stuff fits inside of a thing. So when we're talking about a can, for example, that has a volume, the volume of this specific bev is actually listed as 15.5 fluid ounces. That's the American measurement, or the rest of the world uses the metric system, 458 milliliters. So that tells you how much liquid fits inside that. It's not how heavy it is, right? So again, that can of iced tea is pretty much a cylinder. It's not exactly a cylinder, but for the purpose of today, let's assume that it's a perfect cylinder, right? Now, mathematically, when we think about a cylinder, we're talking about a shape that basically has two circles for its bases. So there's a circle on the top, a circle on the bottom, and we've got two pairs of parallel sides that kind of wrap around this guy here, right? That's a cylinder, that's what one looks like. Now, if we're trying to think about what's the volume of this thing here, the easiest way to try and think about that is similar to what we did last time with those boxes, right? We said, okay, let's think about having layers. So let's say this here had one layer, two layers, three layers. Let's say it was made up of 1, 2, 3, 4 layers, right? I'd be able to figure out how many cubes are in this bottom layer here first, and then multiply it by how many layers I had all together. So we're gonna try a similar approach when thinking about a cylinder, right? But instead of thinking about rectangular layers, because our cylinder has a circular base, we're thinking about how many of these circular layers can we stack up to get the cylinder, right? So in this example here, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8 layers, right? So you can see that if you were to move these top 2 layers down here, I'd be about at the top of the cylinder here, right? So the cylinder here, again, has a height of 1, 2, 3, 4, 5, 6, 7, 8 of these layers are stacked on top, right? So let's say for this example here that 8 is gonna be the height of this cylinder, right? So now on the next page, let's go ahead and see what else we would have to figure out in order to figure out what the volume of the cylinder is, right? So again, that last page, we just figured out that this here is made up of 8 layers, and that's our height, right? Now, the second thing that we would actually have to figure out is how many boxes or how many cubes are made up of this bottom layer here. Because once I know that I have the same number of cubes in this layer, same number in this layer, same number in this layer. So that's the next piece of information that we need to figure out, is how many cubic units are there in just one of these layers here, right? Looking at it from a side view like this, there's no way we're going to count that. So instead, think about looking from the top down. We get what we call an aerial view, and it's gonna look like a circle like this here with a grid layered on top of it, right? So now we're thinking, okay, how can we count how many squares are made up inside here, right? You might start to say, okay, let's start counting the squares. I see 1, 2, 3, 4, but hold on a second. I see part of a square here, right? So I can't count that. And ideally, at this point, you're starting to remember that lesson where we figured out what the area for a circle is, right? And if you're observant, you also saw that it's at the bottom of the paper right here, right? So remember, anytime you have a circle, the area of the circle is found by taking pi, multiplying that by your radius. squared. So that means when we're looking at the circle here, the question that we need to figure out first is what is the radius of this circle? So we need to figure out what's the center point of the circle, right? So it looks to me like this line from here to here is the center of the circle, right? So let's count. From here to here, I've got 1, 2, 3, 4, 5, 6. So this looks like it's 6 boxes long, right? So that's our radius. But be careful what we're measuring, right? I actually didn't measure the radius here. What I measured was the diameter. So I know that the diameter was 6. And we remember the relationship that the radius is always half of your diameter. So if from here to here is 6, I know that from the outside of the circle to the inside, which again, I can also just count here, 1, 2, 3. So the radius we know is actually equal to 3 in this case. So if I want to figure out what the area for this circle is, all I need to do is, again, substitute this 3 for the radius in here. So I know that the area is equal to pi times 3 squared. I know, remember, 3 squared, that's 3 times 3, right? That's not equal to 3 times 2, right? Really sure, try not to make that mistake. So this is pi times 9. Now you're gonna whip out your trusty Android or whatever calculator that you happen to have on you, right? Remember to turn it landscape so you get that nice, beautiful scientific calculator. I'm gonna hit pi times 9, and here is my answer. I'm gonna round it to 2 decimal places, 28.27. So remember what this number is, right? What's the significance here? This number tells us that inside this circle here, there's approximately 28.27 squares, right? Now, think back to this here, right? This circle was the top view of this layer here. So that tells me that this layer has about 28.27 cubes, right? Same thing, this layer here, that layer, that layer. Every single one of these layers has 28.27 cubes. So altogether we had 8 layers, remember, right? So to fill the census out, this tells us that there are 28.27 cubes in each of the circular layers. So the volume of the cylinder would be, sorry, we can't see that, right? So the volume of the cylinder would be, I need to take this number here and multiply it by how many layers we ended up with, 8 layers. So I'm gonna take my calculator now to get the most accurate answer. I'm not just gonna put 28.27 times 8. I'm gonna take this entire thing that I had before and just multiply my result by 8. That's it. So right here is my final answer. I've got 226.19. So the volume here is 226.19. Don't forget your units when you talk about volume. This is gonna end up being cubic units, right? Volume always has cubic units, just like area has square units. So what we're gonna do next is I'm gonna walk you through 2 example problems, and then you're gonna practice trying to find some volume yourself. So, turning to the next page, right? What I did here is I gave you the formula to find the volume of a cylinder. So we know that V represents volume. So it says volume is equal to pi times the radius squared times h. So we know that r is the radius of the circle, h is the height. So this part here, pi r squared times h, that's basically the area of the base of the circle, right? This word base, when I say base, basically think about the bottom of the circle or the top, right? So it's really similar to what we did yesterday, except instead of working with an object that's rectangular, we're working with an object that is circular. So again, first find the area of the base, multiply that by how tall your cylinder is. So I'm gonna walk you through 2 examples first. Over here, we see a cylinder, right? So let's start by writing our equation. V equals pi r squared times h. So we need to figure out what the different parts are of our cylinder so that we can plug these in accordingly, right? So this 3 here, that's the radius because it goes from the center to the outside. So the 3 is going to end up replacing the r in my equation, right? Now, second thing, I have one more number, so that's got to be my height, right? The height measures how tall it is from the top to the bottom. So the 4 is going to replace the h in the equation. Now, all I need to do is rewrite what I've got here. So I know v equals pi times my radius. So instead of r again, remember we're using 3. So my radius squared multiplied by my height in this case, which is 4, right? So now I'm just going to do a little bit of simplifying right here. I'm going to leave the pi alone until my last step. 3 squared, remember, that's 3 times 3, which gives me 9 multiplied by 4. So finally, I get, that's pi, 9 times 4 is going to give me 36. So pi multiplied by 36, right? Now, when we get to higher level math classes, typically you leave your answer in terms of pi. So I would just usually put the pi second. You'd say your answer is 36 multiplied by pi, right? But when we're in 7th grade, part of 8th grade, usually we want to multiply this out. So our last step here would be just to take our result and multiply 36 times pi. And I've got 113 points. I'm going to round to 2 decimal places. So 0.97 goes to 113.1. So my volume is 113.10. And please don't forget your units. So because this is centimeters, my units are going to be cubic centimeters, right? That's my final answer there, right? Now, second question, very similar, but there's one small trick here that we need to make sure we don't miss. So we're gonna start the same exact way as before. First, we're gonna write down the equation. V equals pi r squared times the height. And again, we're gonna look at our diagram, we're gonna identify these things so we know where to put them in our equation. So looking first here, if you're not careful, you're gonna say, okay, so this 8 is gonna go in from our radius, but this is actually a diameter. So if my diameter is 8, remember the radius is half of that. So I actually want to substitute a 4 and not an 8. So this r is gonna get replaced with a 4, and the h is gonna get replaced with a 12, right? Now, we're going to substitute those in just like I indicated with the arrow there. So we got v equals pi times our radius, not the diameter, is 4 squared multiplied by our height, which is 12 in this case. Now, we're going to do a little bit of simplifying. So we've got pi multiplied by, remember, 4 squared is 4 times 4. So this is going to give us 16 and not 8, right? Times 12. Again, I'm going to write down what I get when I multiply these two. So I've got pi multiplied by 16 times 12, which gives us 192. Right, now at this point, you can multiply pi times 192. I'm also just going to write it as 192 pi. And now I'm going to multiply it out. So 192 multiplied by pi gives us 603.19. Again, being careful to round to 2 decimal places. So 603.19. And remember, our answer is not complete until we actually write in those units, right? I'm seeing a lot of people that forget to write their units in, right? So my units in this case were yards, so I can write it like this, or you can actually write out the words cubic yards. So I'm writing it both ways for you. And that's our final answer there, right? So again, just when you're doing these questions, make sure you're always starting off with your equation for volume, V equals pi times the radius squared times h. You're replacing the r with the radius, and you need to be careful with some of these examples. Some of them give you the radius, some of them give you the diameter. So just make sure that you're careful when you're looking for those there. All right, now when you submit your task, I want you guys again to try to show as much work as you can so I can see where you made a mistake. So if you're taking a picture, you're attaching that to your worksheet, or you are typing it out as best as you can, that's gonna help me to help you, right? If I only see an answer like say 500 here with no work, I can't tell what you did there. I can't really help you out there, right? So at the minimum, let's try to have this here down. What times pi, so I can try to backtrack and see, okay, how do they get that number there? But I would prefer if you put as much work as you can. We should have this here followed by what we got when we multiplied everything times pi, right? So you're gonna work on the rest of the questions in part 1, and then when you get to part 2, some of those questions are a little bit harder. Just take your time with them, practice them, all right? We'll be on the Zoom session. If you have any questions, feel free to ask Ms. Heidel around, all right? Good luck.